G'day, Michael here. I've changed the platen design here a little bit, giving myself better adjustment. And unfortunately the height was incorrect, and I was doing a very large extended print. You can see the dregs of the first circuit that I did. But in the process of just hitting the platen the first time round with the delta fully extended over this way, probably hit it with about a collision of about 4 millimeters into the bed, and that produced a failure. This part basically broke. Here I've got this 3-leg bearing design which has been working quite well, but basically that was the end of its life. Now what I want to do now is replace it with a 4 bearing design. So I'll have 2 top and 2 bottom, and get rid of this center one. Unfortunately, I've ordered the bearings, but they're coming from China or wherever, and they'll probably take a few weeks. So temporarily I have to use a 3 bearing design on remaking these parts. So I'm intending to replace this, like I said, with a 4 bearing design. But I thought, well, I can do something to give both options in the design, so I'm doing that. But also, this being printed, I had this, if you imagine it down on the platen, I had a lot of support material, and you can see this daggy material in behind here. That's a result of the support material and it not being fully supported when it comes to print, because obviously it's sitting on the support material. Whereas when you print something directly off the platen, it takes on the surface of the platen, which is a much better surface, a very strong surface. So what I've decided to do is split this unit at this line here, at this plane. Okay, and then I'll screw the 2 parts together. That way I'm printing with pressure from the very first layer on, and so I'm printing backwards this way, and everything will be nice and strong through that way, rather than having this layer which doesn't have much pressure on it when it's being printed. So it should be a far superior print. Okay, so there's a few design issues with that. I had to change the footprint of this, obviously, and I obviously had to allow for some way to screw this together, and in this design there's nowhere allowed for that. So let's go to the design computer and I'll show you what that's all about. Okay, so you can see there's 5 legs on this, but I can use 1, 2, 3 temporarily while I've only got 3 bearings to work with, but when the other ones turn up I can use the 4 corners. The other thing I've got here is a expansion or contraction area, an area I can compress with a screw to make sure there's good tension, or good pressure I should say, really, on those bearings onto that post, because I want to really firm this up and beef up the strength. And here's the other part, which I've had to add a whole larger platen sort of thing on that piece, whereas before its footprint was basically that big on here. One part's inverted to the other, so I've got both of those where the joint surface is actually down on the platen when it's being printed. And you can see, well, it's quite a lot more complex than the first one was. Let me just move this around. Oops, sorry about the shot. Okay, so in here I've got a recess for a screw head. So going straight through here, I can put tension on there to tighten up that bearing. Other than that, it's basically the same physical working dimensions as the previous, except the center point for the tie rods has moved down 20 millimeters, so I'll have to make an adjustment in the printer config for that. And what I mean is this business. Hang on. So what that meant is this center point has gone down 20 millimeters based on what this is to the new design. Alright, so I've got it in the Cartesian being printed, so let's have a look at that. Now basically this is a mock-up I'm using. Basically I'm going to run out my ABS because I'm not using it for the larger parts. It's a bit problematic, and it's fine for smaller parts, sort of 100 millimeters or smaller. Gives very little trouble there, but when you get onto bigger bits it can be a bit of a nuisance. I'm also playing with a lot of other different materials, PETG and obviously PLA works quite easily on larger parts, but I'm finding ABS is not worth the trouble. It does produce good small parts and reasonably good finish, etc. Yeah, but when I'm happy that this design is actually correct, and good, I'll be printing it with polycarb because I quite like the strength of the polycarbonate, ABS polycarbonate. It's basically 10% polycarbonate. Okay, well, not much to see here. I mean, this is just going to do what it does. Yeah, well, I guess that's it. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.